Aarne, and I'm going to talk about thinking clearly. That's like thinking more objectively, more formally, so more clearly. And I have thought myself that I'm on this quest to think more clearly. And why is this? Well, at young age, I was exposed to this philosophy. Strange thing that really makes your mind go around. And I was interested in logical fallacies, such as paradoxes and similar. And I'm also interested in teaching others to see those fallacies that they make in their everyday life and own thing. So next I'm gonna tell you 3 stories. First one is kind of story that corrupts a young mind to think about these things in more focused way. So there's this war hero. He has been in great sea battle, defeating all his rivals, and now he's coming back to his hometown. And the citizens cheerfully welcome him, and they want to preserve his boat as a symbol for this great victory. And they park the boat on the harbor and remember the great battle they had won. And years go past, and the wood in the boat starts to rot. So they are forced to replace some of the rotten wood with fresh timber. And this goes on. More parts are going bad, and the ship is going to sink if they are not repairing the ship. And along comes a time when the last part that went to that glorious battle is replaced because it's rotten. But the ship itself is exactly like the one that was in the battle. And the question comes, is that still the same ship that went into that battle? Some of you may notice that this is a rather famous paradox. It's called Theseus' ship. It's a Greek paradox, and it really makes your mind boggle about okay, is this the ship? Okay, it has nothing the same material as the ship that was in the battle. So is it the same ship? Well, these are the paradoxes that really challenge our common sense. And there are alternative ways to think about this situation, but none of them are comprehensively good ways to understand. And I'm this is very interesting. I want to focus on these more in the future. And there's this one paradox expert who's master of using paradoxes in his teaching. The name is Socrates. You might have heard of Socrates and his method. And next I think I'm gonna tell you a story about how Socrates uses this method. So it's a story about Hippias. Hippias is a very famous teacher. He had been long abroad in foreign lands teaching other people. And he boasts that he can give lecture on anything on Olympia without prior preparation. So he's rather famous and popular among the young people of Athens. And that's why Socrates is very interested in meeting this guy. He goes to one of his lectures and asks him about, can you define beauty? What is beautiful? What is the essence of beautiful? And Hippias is rather flattered. So Socrates, this also famous guy in Athens, comes to his lectures and asks very humbly, what is beautiful? So of course Hippias is like eager to answer. And the first definition he gives is that a pretty woman is beauty. So a pretty woman is beautiful. What do you think of this? Is this a good definition of beautiful? Neither was Socrates happy. So he gives a counter example. Can a pot, clay pot, can it be beautiful in one way? Or what's the beauty of this pretty girl compared to Aphrodite, the goddess, the beautiful goddess? Like, there's some levels of beauty in each category, so you have just given me an example of beautiful things and not the essence of beauty. So Hippias is like, give him a second example and says that gold is definitely the most beautiful things. Everything can be made more beautiful with gold. If you cover like anything with gold, it's more beautiful. So gold must be beautiful. But are you like convinced of this? Neither was Socrates. So he says that, what about the pot? Does it need to be gold? Or there are plenty of statues in Athens that are made of precious stones, and they don't need any gold to be more beautiful. So it was this definition good. And Hippias gives some other examples, but those aren't good either. Socrates proposes that, what about popular things? Are those of beauty? And Hippias is, yes, that's a good definition of beauty. So popular things are beauty. What do you think about this? No, not good definition either. And Socrates is like, okay, something made the thing popular, so it can't be popular just based on, we can't define beauty based on if that's popular, because there needs to be something that made the thing popular in the first place. So after this dialogue, they both are rather annoyed or like frustrated with things, and Socrates says that things of beauty are of difficulty. So they are very annoyed, and the crowd is annoyed, like, how can this great teacher define something so simple as beautiful? Their minds are like, why can't this be? And as you might see, this kind of questioning of even the most simplest thing led great deal of anxiety in Athens, and later it led Socrates to lose his life, but that's another story. But the essence of this method is questioning every assumption we have in formal way. And you could say that it's also the essence of science, to question every assumption we have. So my argument is that Socratic method is very good way to think more clearly. You question every assumption you either yourself or anybody else comes up with. You can always ask why. So this is the method of science. And for the last story, I would like to illustrate how I used this method when teaching other people to code, like programming skills. And it was around a year ago. I was course assistant in this programming course, where freshmen are learning basic programming skills like classes with Scala, like if statements, variables, that sort of thing. If you are familiar with programming, you know. So programming is basically thinking clearly. Programming is thinking in a formal way that makes sense and results some, because you need to be very formal when you talk to computer. This course that I was teaching with, as a helper of the professor, there were other senior. I wasn't the only teacher in that class, no worries. But the task was pretty broad. They were given open questions and given openness in how they could solve it. So I couldn't know certainly what the individual freshman group wanted to achieve at a specific time. So there was no way to prepare for any of the tutoring that we had in that class. And it was one very late time at Tuesday. The deadline was set on Wednesday, and there was this group of freshmen in the campus hangout space, very frustrated with the late hours studying and trying to fix their code work to the Wednesday deadline. And they gave me the happy face look, like, please help us. And of course I was forced to help them. And conversation went like something like that. And I come to the table and ask, like, what's the problem? What do you want to achieve with this your program that you're writing? And they would tell me that, okay, there's this function that gets this list and value, and it should check if the value is on that list and then return a boolean to this other class. And I was like, okay, I have no idea what's the specifics here. And asked what's the problem then? And they answered, it doesn't work. I'm very okay, now what? Let's look at the code. And I tell okay, that might be a syntax error. That looks like an array, like you're using wrong method for wrong object in this programming language. Let's what's the correct one? And she didn't know, and I was like, okay, let's Google, and we did. Actually, this for you. Programming is not about Googling in a formal way, like understanding what to Google. It's the how you know to program. Well, but now we Google and get the correct syntax that is list dot contains value in the parentheses, and that works. But the girls are puzzled, what now? Okay, this is now, and what we need to do now? And I'm like, okay, remember, what was the purpose of it? The purpose of this program you're writing. You should read it aloud. Read it aloud to me, the code you just wrote. And they do. Okay, this class gets this list and then the value and the if statement we just wrote here checks if it contains and I'm like, and what's the next step? It should return boolean. They answer me. And then I ask how to return boolean, very simple, dumb question. And they're like, of course, you just write return and this if statement gets the value from there. And then the next step, how to check if the code works. They are like, unsure, what's the next step? And again, I'm like, and the next step should be, and they realize that, okay, now we should test this code we just wrote in the other class that uses this class as or this function we just wrote. And we do, and the code starts to work. So as you might realize, I didn't know anything specific about the task they had. I only knew how to think systematically when it comes to programming Scala, but I didn't know the exact answers on how to write the code that they just needed to write. So I asked these questions from them, and they need to think in their own minds how to answer these questions. And the greatest moment of this was the instant feedback that one of the girls gave me. She said, you were acting so dumb. You were so dumb, but it was just like you knew all the answers, but you just acted so dumb and wanted us to give the answers. Why couldn't you just give the answers by yourself? And in that moment I knew I had succeeded as a teacher. I had forced them to use their own brains, use the Socratic method to structure their own thinking and force them to think logic, formal logic way. That is the Scala code they produced. And I think this summarizes what I wanted to say. I hope that these stories or paradoxes might have irritated your mind or forced you to join me on this quest to think more clearly.